Hello mate, and welcome back to this Ren'Py Masterclass. What I'm going to be talking about in this game is I'll give you a quick overview of how the drag and drop system I've created here works by using a mixture of Ren'Py, Python and screen code. Now this is not going to be a copy paste code tutorial, so if you are expecting to see the full code for this file, you will see the full code for the file, but I'm certainly not going to be talking you through every line by line. I'm simply going to be explaining the concept of drag and drop and the concepts of mixing Ren'Py, Python and screen code. So what we can see in this file is that I've actually got a screen here, which is a shop screen where the player can buy different things, and as you can see that when I'm calling the screen, I'm actually adding a faction property into that screen, and what that means is that I can have multiple shops that all use this same basic screen, and then the faction that we enter in the command when we call it will determine which items will be shown for the player to buy. Obviously in reality, a game will have a list of items that are available in that game, and that might be hundreds or thousands of items, but they will all be contained within the same list. So any game where you have to travel to a certain location, or you have to go to a certain shop to buy those items, that's just a game mechanic. You can call it time gating, you can call it whatever you want, but the fact is that basically the same shop interface will be available in all of those places, and they will just access the list depending on where you are, and that's essentially what's happening here. So we've created a frame with a scroll bar, and then we have a list, and in this list, buyables, as you can see, I'm going to run through the list by using a for loop for buyables in buyables. Now this is Python code, so that is a little bit outside the scope of this masterclass, purely because the idea is that this is Ren'Py. So if you are interested in using Python code, you can absolutely do it, but you will need to spend some time learning Python coding outside of this masterclass for certain. So we scan through our list of buyables, and then we're saying if buyables.faction equals faction. In other words, if the buyable has a property called faction, which is stated down here in the class, which we'll talk about in a minute. If the faction of the buyable is the same as the faction that we've stipulated at the top of this screen, then it will create a button which will show you how many you currently have and allow you to buy it. There's also a close button here which simply returns the word quit to wherever the screen is called from. So that's essentially how that screen works. So we're going to close that down. Then we've got a number of styles here that we're not really going to talk about because we've already discussed styles. And then we've got our actual classes. Now it's important here that I've used copy. One of the problems that people run into when they start working with classes is they don't understand the terminology, they don't understand referencing. And if we want to create a copy of something, we can't just say x equals y. We have to say x equals a copy of y. Otherwise, any changes we make to x will also affect y. Okay, when we're using classes. So we need to use the copy module, which is a Python module. Okay, so we've got a class. A class is an object, and it is literally an object in memory, and it's an object in real life. So we've got a thing. So let's just say that when you go and do your grocery shopping, everything that you put in your trolley or your basket is a buyable. It's something that you can buy, and that buyable has properties. For example, a name. It might have a name that the people in the shop refer to it to, and then the nice name, which is the name that is printed on the packaging. That's the name that everybody is marketed to everybody as. Then you can see we've got the faction property, which for the purposes of this analogy, let's say that the faction is actually the shop in which you buy it. So whether that's Walmart or Tesco or something like that, that would be what that property is. Rep is, do you need to have a certain amount of reputation with that faction in order to be able to buy this item? Now I haven't actually implemented that in this code thus far, but there's a property there for it. and then it will just simply be a gate that says if this rep value is not high enough with this faction, then just don't display the item in the shop. The cost, that's obvious, how much it's going to cost. If the item is active, so you have the ability to switch on or off these objects, so maybe there's a certain point in the game where you want the item to become available in the shops, but you don't want it to be purchasable before that, you can set this property there. And again, this is, I wouldn't call this time gating so much as making sure that people can't just rush through the content. For example, if you've got a game where you can buy different houses, for example, you don't want that person AFK farming and then just going and buying the biggest house. You want them to actually play the game properly, and by adding this property we can actually turn off the most expensive things so that you can't buy them until you've reached a certain point in the game. So it's not for everybody, but it's certainly something. Then stack is how many we can get into a single stack. So for example, if it were talking about houses, then you'd only want one. If you were buying cans of soda, maybe you want to have a stack of 10 or something like that. So this means how many times can each one stack in every cube or every square of our inventory. Quantity, fairly self-descriptive, that one, how many you've got. Description, so in the shop, if we go back to our shop screen, you can actually see that we use the description in our button inside our shop. So it shows you the nice name and it shows you the description, and that just means that the shop actually has, you have the ability to put some text in the shop that will tell the player what the item is for, what it does, or just some meaningless text about it. And then is quest item. Now this one's important because there are going to be certain items throughout the game possibly that you don't want the player to be able to delete. Now, I would imagine that most of you have played a game at some point where in the inventory you have quest items and you can't do anything with them. In fact, some games don't even let you move them from square to square, which can be quite annoying if you've got OCD, because you want everything to be where you want it to be. And having it dumped wherever the game decides to dump it is not necessarily to your liking. So this flag has, is basically to allow you to control whether or not the player can delete the item. Then we've got an icon property. It's got the property decorator above it, which means that we don't have to use brackets when we actually call it. We can call it as if it's one of these values. And all it does is returns the file name, which is a combination of this URL here, UI icons buyables, and then we're using the format command to replace these curly braces with whatever's in the brackets there, self.name. So each one of our buyables must have a unique name, otherwise they're all going to use the same icon, or the ones that we have the same will use the same icon. And then we're checking if renpy.loadable, if we can load the file that we've declared using this command here, then we'll return that value. Otherwise, we'll return a default icon so that we don't get any crashes when we try and run our game if we forget to create icons for our buyables. This next one is again something that I'm in the process of working on but haven't implemented yet. And then we have some functions. Buy item, check if has item, and define buyables. So we're going to skip over these two for now, and we're going to come down to define buyables. Now this is pure Python code, so at this point we need to understand some basic principles about Python, but remember this is not going to be a massive Python tutorial, so I would encourage you to go and spend some time doing that outside of this class. The first thing we have to do is tell Python that we are using the global buyables variable. So remember the list of items that we created, or that we are creating, because at the moment this list is empty, but this is the variable, and we're telling Python to use the global variable, not the variable that we create inside this function, because if we create the variable inside this function, it will only be accessible in this function, and we want to use the one that everything else can access. So we've created the global variable buyables. Now fname equals renpy.file data items.xml. This means that I have created an XML file which contains all the information about all of the buyables that I need. Then we're going to pass that file name into Python or into the eTree functionality, which is another module that you can use. And then we're going to find all of the buyables. So you can actually, there's a lot of items in that file that are not buyables. Again, I'm not going to talk you through the specifics of how to use these modules because it's outside the course, but I'm just explaining how this whole kind of system comes together. And then all we do is we pass through each property of our buyable from the XML file actually into the Ren'Py properties, and then we append them to the list of buyables. Okay. So if I were to go into my data file, my XML file, you can see that this is an XML file which just has all the information about all of the buyables currently contained within the game. And they all have the properties, name, nice name, faction, rep, cost, is active, stack, quantity, description, and is quest item. So those are all the properties that we've created for our class. And all we're doing is we're using eTree, which is the module, to basically pass that into our list. And all this means is that we can create a nice tidy looking XML file to create all of our items rather than just a bunch of declarations inside our Ren'Py code. There is no right and wrong way to do it. In this case I've chosen to use XML, but you can just do it using Ren'Py and just literally saying buyables.append and putting in all of the variables yourself for each item. Entirely up to you. Okay, cool beans. Now, go shop faction. So we have created, or we've defined a function called go shop and then in brackets faction. What we're doing then is we're setting the flag of in-shop to be true, which is a variable that's used by the UI and other parts of the game. You don't need to worry too much about that, but saying in-shop and then we're going into an in loop. So we're also saying that in-shop, while we're in the shop, we're going to stay inside this while loop, which means that buying an item from the shop isn't going to dump you out of the shop screen until you hit the quit button, essentially. Saying UI return equals renpy.callScreen shopping and then faction. Okay, so we're calling that screen that we've defined at the top with the faction property in it, and then it's saying if UI return equals quit, then we're going to dump out of this loop and we're going to tell the game that we're no longer in shop. That's basically all we're doing in this one, because the screen for shop, if we come back up the shopping screen, you can see that we're actually calling the function buy item and then we're inserting the buyables.name into this function when we actually hit the buy button. Buy item is this function. So we're calling this function from the screen, so we're not doing it from this Python code down here. So we're going to stay in the screen until we hit the quit button. Okay, so buy item. Now you can see we've got the globals of our inventory, which is just a list that is declared in our inventory file, which we'll get to in a minute. As you can see, that is currently just a empty list, or a list full of none 100 long, so 0 to 99. Okay. Then we've got our buyables list, which we've just finished creating, and then we've got MC stat, which is basically just so that we can access how much money the character has, the main character has in this case. Don't worry too much about that. I've just basically got a list of stats called MC stat, and then we're just accessing whether or not the player has the right amount of cash in that. We'll talk about that in a moment. So item number equals -1, existing index equals -1. So we've got these two items so that we can basically set them a bit further down. So for items in enumerate buyables, we're saying if item's name, so we're going through our buyables list until we find an item in our buyables list whose name matches the name that we've passed into this function. Then we're resetting item number, the value that we've just set to -1, to being the item number of the item in the list of buyables. So we're basically saying once you find the item in our list of buyables that has the same name as the name that we've entered into this function, then set our item number variable to be the index in our list of this buyable. Okay, this means that we can interact with it a bit further down in the list. Now we're going to say the MC stat cache is going to be reduced. We're going to take away the cost of the item, buyables item number cost. from our MC stats. So we're taking the money away before we do anything else. The most important thing, take the money. First rule of business, take the money. Okay, now we're going into an inventory. In inventory equals false. Then we're going for invent slot in enumerate invent. So we're going through our inventory. This is where the number of slots that we have in our inventory is going to become important. And we'll go into the functionality of that in a moment. So we're cycling through the inventory, and then we're saying if there is if it's not none, basically. So we're going through our list. If you remember, at the moment, our invent list is just a list of nuns, 100 nuns. So we're saying if it's not none and it's not recycle, then we will check to see if the item in that slot is the same as the item that we're currently looking to store in our inventory. If it is, then we will add it here. Okay, and then as you can see, we're using copy.deepcopy to copy an item into our inventory slot. Okay, then if you remember, the reason we're using copy and not just saying existing index equals invent slot 0 is because we need to create a copy of it, not a reference to it. Otherwise, any changes we make to what we have in this index is going to be completely buggered when we make changes to it. So we're going to end up with all kinds of wacky stuff happening with our inventory. Okay, so if we have it to being, if we have the item in our inventory, so we've now determined that we've already got one of these in our inventory, the item that we're about to buy. If the existing index.stack, in other words, if we have more space in the current stack than we currently have, so we're checking the stack property. If the stack is 10, for example, and we've got 5, then we're golden. Then we can say add the existing index quantity by 1. Okay, now I realized that I got my models worded up a little bit there, so I'm going to re-explain. So all we're doing in this one is we're determining whether or not we already have the item we're trying to buy in our inventory. And if we do, we're adding our existing index number, which you remember here we set to -1, is going to be this item here, or rather this slot here. Okay. Now we're going into and we're saying if we do have the item in our inventory, and if the number that we have is not greater than the maximum stack size, then we'll just we'll add 1 to our stack. Nice and easy. Now, if that is not the case, if we don't have it in inventory, then we need to find our first empty. So we're going to say first empty equals invent index 1. Now this is Python code. Basically, we're saying invent.index is going through our invent list, and we'll find the index in that list of the first none property, or the first none variable. Okay. I appreciate this is heavy going. Okay, this is Python, going reasonably deep into Python at this point. So again, I'm explaining to you how it works. This is not a copy-paste code exercise. Don't copy-paste it, because then when something goes wrong, you won't have a frigging clue how to fix it. Make sure you understand the principles at play. So we're using invent.index none to find the first index in our list that is equal to none. Then we're going to say the index of our first empty space. We're going to deep copy the buyable's item number into it. So we're going to find our empty space and we're going to add it to our list. And then we're going to increase the quantity by 1. Nice and easy, yeah? That's basically how that part of the drag and drop inventory works. This is, believe it or not, I would call this still fairly beginner / intermediate level Ren'Py Python coding. But again, like I said before, like I keep saying in this tutorial, it's important to understand the structure of the code and how everything does what it's meant to do. Otherwise, when it comes to actually trying to implement this yourself, you're not going to have a clue what to do with it. And there's going to be all kinds of errors because you're going to make typos and you're not going to be able to spot them. And you know, so it's very important to understand what's happening, more important than what I've actually written. Okay, so the last function I've got inside the shopping file is check if has item. So all we need basically a function that allows us to check if the player has actually got an item, so that when we have items that you buy that are quest items, we can actually find out if the player has the item that's required. So we've declared that we're going to access the global invent and the global buyables variables. In inventory equals false at the moment, and then if we have it, we're going to set that to be true. So we're going through our inventory again, we're just scanning through it, and then we're saying if the invent slot 1, don't worry too much about the 1 at the moment, that's just because we're enumerating, so it returns a tuple and not just a single variable. So if we go through our list, if the value is not none and it is not recycle, because we've set one of our boxes to be the recycle bin, which we'll cover in a minute. If the invent slot 1 is called the same thing, in other words, if it shares name variable that we've passed into our check if has item, then we'll return true. Otherwise, no, we don't return true at all. Okay, nice simple function, fairly simple stuff. I'll talk through it again though, just to make absolutely sure. I'll try and explain it in a more clear way. Right, so if we have an item in our game that we need the player to be able to buy or collect from somewhere that is required to progress a story, or for whatever reason, we want to be able to check if they have the item in their inventory or not. So what we've done is we've created this function which accesses the global inventory list and the list of buyables. This in inventory variable actually doesn't do anything in this function. I've added it in there because there was some functionality that I was going to add, haven't got around to it yet, so don't stress too much about what this one is. What we're doing is we're going into a for loop that's cycling through our inventory. And then we're checking for each item in our inventory if it is not none, because remember that our inventory is basically a list of nones that we replace with stuff when we buy an item or we collect an item. So if it's not none, and if it's not the recycle bin, then we're going to check if invent slot 1's name is the same name that we're checking to see if we've got, then we'll return true. Otherwise, it won't return true, i.e. it will return false. Now let's go into our inventory file, and this is where things can get a little bit crazy because people can get lost. But our drag and drop system is basically this bit of code here, okay? And we're using drags and drops. But before we do that, let's talk about this little bit of Python code down here. And this is all the Python code we need to make this screen do what it's meant to do. But the first thing we have is if drags placed, which is, define the function at drag placed, which takes in drags and drops, okay? So we're saying global inventory, so we've passed into it our inventory, of course we have, because we need to be able to access it. And we're saying if not drop, in other words, if we're dragging the item but we haven't dropped it yet, then we're going to just return out of this function. We're not going to do anything because we don't want it to do anything until we've actually dropped an item somewhere. Okay, now we've got our store.dragged and store.dropped. Store is just the place where Ren'Py stores all of the variables. Basically, we've got two stores. We've got store and then we've got the persistent. Store is specific to your saved game. Persistent is specific to all of the saved games. Okay, and then we've got drag name and then drop drag name. So let's go into our screen so that we have a little bit more context as to what's going on here. So all we've got is our bits and pieces up here that just determine the size of our grid, and then we've created a frame. The frame is just the background, okay? don't worry too much about it. It doesn't do anything this frame. It doesn't have any functionality. It just adds a background so that there's some kind of thing separating the background or the inventory bit of the screen from the rest of what's going on the screen. Then we have to create a drag group. Now this is very important. You have to create a drag group in order to use drag and drop functionality. If you don't, you can drag stuff around the screen by all means, but you can't actually do anything with it. You can just move its position, which arguably has some functionality, but arguably not. Okay, so our drag group is just a grid of X and Y size drag scale, drag scale. And as you can see, drag scale is a variable up here that just determines how wide or the size of our frame is going to be. And then we're going to scan through for every invent number / invent slot in our invent, right? So this is using enumerate again. When we enumerate through a list, it returns a tuple. It returns the first part of the tuple is the index number. The second part of the tuple is the actual thing that's contained within that memory location. Then we create a drag. The drag name is going to be the number, okay, inside the inventory. And then we're going to use slots.png. That's just a background image for the slot of the item in the inventory. Or rather, in this case, it'll be an empty slot. And then we're going to set its position. Its XY position are going to be the coordinates. And again, we'll cover where these coordinates come from in a minute. This is going to be not draggable, but it's droppable. Okay, so this is basically an empty hole that we are saying is going to be there in our inventory screen that cannot be picked up and dragged. So you can't just click it and move it, but you can drop things into it. Okay, so for each slot in our inventory, regardless of where I've put it on the screen, ignoring all of this bump up the top about positions and whatnot, I've created 100, because we've got 100 items in our invent list, 100 boxes in my inventory that cannot be moved but can have things dropped into them. Then what I've done is I've said if the invent slot's name is recycle, sorry, not recyclable. What the hell kind of word is that? When we create, instead of this, we create a drag, which has the drag name recycle, and we add that the recycle bin, and then we're going to say it cannot be dragged but can be dropped, and then we're going to say the position of that is again going to be accessing the position of the item number in the list. So for the recycle bin, we actually add this and this, but we put this, the recycle bin, on top of this so that we can interact with this one. Now we get into the bit where we see if it is not an empty slot, then we're going to be coming into this section of code here. Okay, so we're saying if it's not none and it's not recyclable, then we're going to create a drag, and it's going to be, again, the index number is going to be the number in our inventory list. And then inside that, I've created a frame which has got the icon for the item. The XY size is going to be the size of that icon, and then the text in the bottom right hand corner that just tells us how many we've got, the quantity value. Okay, then we've got position, invent coordinates, blah blah blah. That's just the position of it. Now this one is draggable, but it's not droppable. And when it's being dragged, we call drag placed. Drag placed. Where have I heard that before? Oh yeah, that's this. Okay, so once we've picked up our item, then it's going to start calling this, and then once we've dropped it, it's actually going to have some kind of function. It's going to do something. So let's have a look at that. So we're accessing our dragged and dropped. We've picked up our item. Now GDT swap positions is just a function that I've created. GDT stands for Game Developer Training, if you hadn't figured that out. That just swaps the positions between the dragged and dropped items in the list, basically. So it takes the thing that I've got hold of and it will swap it with the thing that I've dropped on top of. So if I'm dragging from position 1 to position 5, if there's an item in position 5, it will move that into position 1, and then it will take the thing that I had in position 1 and drop that in position 5. So it'll just swap them over. Otherwise, we will double check. For example, if we've said, so if dropped is not equal to recycle, then we'll swap whatever we've picked up with whatever's in there. So if, for example, the item in position 5 is none, then it's going to swap with none instead. Nice and simple. So it's that simple. Drag and drop is that simple. The only time we need to check if it's done something else is if we have our invent int dragged quest item. In other words, if our item is a quest item, then we're going to show the screen, notify screen saying cannot delete quest items, because we cannot recycle quest items. Otherwise, it will just say call in new context, recycle item, int dragged. And as you can see down here, call in new context just means shut down the UI, start in a new context. I'm going to call this num, which is the index of the dragged item in our inventory list, and then we're going to just delete. Basically, that's all we're going to do. So as I said, this is not a copy-paste code exercise. I'm not teaching you how to program in Python right now, but you've probably gleaned most of what you needed from pausing and whatever if you wanted to do that anyway. Sort of defeating the purpose of the tutorial, but there you go. So that's essentially how a drag and drop inventory kind of works in this case in my game Deeper. You don't have to do it this way, there are other ways, but the most important things that you definitely need is that in your screen code you must have a drag group, and you must create your boxes, the things that you're going to be dragging into, and set them to be droppable but not draggable, and then the items that you want to be draggable have to be draggable, drag raise, doesn't matter, and then dragged. When we have the dragged, we have to call the Ren'Py or the Python function that actually tells Ren'Py what to do once we've dragged that item. Otherwise, we're just going to be dragging them around the screen and aimlessly they're not going to be doing anything. Okay, so once we've done the drag placed function, then that's where this bit here comes in. Okay. So thanks very much for watching that, guys. I hope you found that useful. Let me know what you think in the comments below. I will see you in the next one. But until then, you take damn good care of yourselves, all right? Bye-bye.